The next reaction we're going to discuss is a catalytic hydrogenation reaction. In this type of reaction, we reduce a double bond by adding two hydrogen atoms across that bond. So in this case, we're going to add hydrogen gas and a metal catalyst. You'll often see platinum or palladium or nickel. This will result in the addition of these two hydrogen atoms and a reduction of the double bond. One way to think about this reaction, without going through a mechanism really, is that hydrogen gas can be split into a hydride and a proton by the metal catalyst. This can then undergo an electrophilic addition reaction, similar to what we've seen before. This is not the best mechanism, this is certainly an oversimplification, but if it helps you remember how the reaction works, then this is one way to look at it. An important factor of catalytic hydrogenations is that they will proceed in a syn addition manner, just like hydroboration oxidation reactions will. So if we're adding hydrogen across these bonds here, we have the hydrogens being on the same face in both cases. This will actually generate two different diastereomers, because this stereocenter stayed the same while the other one changed. So this is important in some situations. Why does this syn addition occur? Again, let's take our substrate here. We're going to simplify it a little bit, remove that one methyl group, rotate it, add in our pi bonds, and now let's think about how this works with the metal. A palladium metal surface is a heterogeneous catalyst, which means it's not in solution. You can actually see the palladium catalyst in solution as a solid. What will happen as one of these molecules approaches the palladium, the p orbitals of the alkene, the pi bond here, will coordinate with the metal on the same face. And then the hydrogens, which are also attached to the metal, will react with the molecule. So in this case, all of these hydrogen atoms will react with the bottom side of the alkene. The molecule could flip over the other way and essentially be reacting on the top side here, which would give us the other stereoisomer that we're looking for. So to summarize this, catalytic hydrogenation reactions add hydrogen across the pi bond, and they result in syn additions.